Hello world, we are in Estes Park, Colorado for the Keystone Symposia Modeling Viral Infection and Immunity. My name is Anelone, my two guests of the day.
Hi, I'm Ruy Ribeiro. I work at University of Lisbon in Portugal, and I do models of viral dynamics and immune response, typically within the host, what's happening when IgV replicates or hepatitis C replicates and the immune response against it.
And I'm Chad Wells. I work at the Yale School of Public Health. A lot of my modeling focuses on acute HIV infection, typically focusing on cell-to-cell infection. I also have interests outside of virology and immunology, and actually do some focus on vaccination behavior and that effects that it has on disease outbreaks.
We heard great talk this morning, so can you tell us a bit what was your highlights of the day?
Yeah, so this morning we had a lot of, or several talks on spatial infection and the control of infection. To me, I think one of the most interesting things was seeing the way cells are recruited, T cells are recruited to fight the infection at the specific site of infection. There was two talks about herpes simplex virus, and another one very cool talk on infections in zebrafish as a model that can be very well analyzed. And perhaps to me the most puzzling question is that we always assume, and these talks showed, that cells, T cells, CD8 positive cells, kill infected cells, but it doesn't seem that from a quantitative point of view that there is enough cells to kill the infected cells, or that there is enough death among the infected cells to explain the beautiful control of the local viral infection that the immune system manages just with killing. So this is something that I think will be a topic for future research for quite a while.
On that point, do you think we require more knowledge on the cytolytic and non-cytolytic mechanism of CD8 plus T cells, or do you think that few number of CD8 plus T cells have a greater killing impact at different locations?
I think we need two things. One is what you say, a better understanding, perhaps quantitative understanding of the cytolytic versus the non-cytolytic effects. And right now, the techniques are geared towards analyzing the cytolytic effects more than the non-cytolytics. But the second thing is perhaps we can also try to understand more what's happening to the target. So what is happening to the infected cells? And for instance, apoptosis can be measured by looking at what are the outcomes, the remnants, what happens to the cells when they undergo apoptosis. But we don't know how long those markers of those stay. So it's hard to make a dynamic view of how fast the cells are dying. And this is something that if we would have a little bit more information, then we could perhaps see. For instance, if the number of cells that one T cells is estimated to kill per day is consistent with the number of dead cells that we actually see. So I think that, and then there is where this conference brings two approaches together that will be very important to analyze this. One is experiments, and the other one is modeling and quantification of those experiments.
Probably the highlights for me today so far were the just noticing cell-to-cell infection within other systems besides HIV and how they're modeled, and sort of really gave a good talk on hepatitis C infection and how we can sort of analyze these sort of spatial clusters of infected cells. Just with I have a more mathematical background, so it's more the methodology is how we actually implement these types of dynamics, and that sparks my interest. I guess I'm still a student of learning the immunology, so a lot of the imaging that we've seen that Ruy was discussing, I found like extremely fascinating because it's something very new and, I don't know, exciting to me, the fact that they're capable of doing these types of things. And learning new things about various types of viral infections that possibly I can apply some things that I know from epidemiology and maybe other fields that might be able to be beneficial to modeling different viral infections.
I think that more and more we need people with a quantitative analytical background, if for nothing else because there's more and more data, massive amounts of data being generated. And if you want to extract information and insight from that data, you most likely need to quantify, be able to do quantitative analysis, not necessarily just modeling, but quantitative analysis. And models can provide also important help to understand the data. And so one skill or two skills is be able to develop models, but to also talk and understand the experiments. And on the other side, people that do experiments that also have a more at ease, that are also more at ease with modeling and understanding what modelings do. So it's often you see people, and I don't think this happened this morning, but you often see people that when they present saying, I'm a modeler, I don't know anything about the experiments, but this, or you see the opposite, say, do the experiments, I don't know anything about the models. And okay, that's fine, maybe there's room for that, but I think that the people will be more successful in the future, and where there's more need is it people that say, I'm an experimentalist, but I love models and I'd like to understand more, and I'm a modeler, but I love experiments and I'd like to understand more. So there's definitely, I think, a lot of room for new ideas, new people to come in and work in this area. It's sometimes a difficult area because it's multidisciplinary, interdisciplinary. There's multiple jargons that you need to know, but it's an effort that I think it pays off in the long term.
People have to have double degrees, double PhD in immunology and mathematics. What are your views on that?
My view is just being trained as a PhD in mathematics is, if you find a field interesting, you're going to read enough about, you're going to basically teach yourself the immunology and biology associated with these things. So I don't really think you need the double degree. It would be, if you're interested in something, you're going to take the initiative and start to learn about it. And having mentors like Alan Perelson, Ruy, and everybody else attending this Keystone meeting could guide people such as myself, not familiar with the immunology and biology associated with these infections. And I think that in itself would allow more younger researchers to possibly enter fields such as this. So let's say you had a biology student who's not, sort of, I'm going to say, intimidated by the mathematics. Well, you could sort of take them under your wing and start teaching them. If they're interested in the mathematics, then you can take them under your wing and sort of start teaching them the aspects of and benefits associated with mathematical modeling. And they're going to understand the more experimental part. And as Ruy suggested earlier, you want to try to bridge that gap between experimentalists and the modelers, where everybody's sort of on the same page and everybody sort of is not saying, well, I'm a modeler, I don't really know much about the experiments. Personally, myself, I'm trying to learn more about the experiments where I can sort of better incorporate the biology within the models that I'm more comfortable with.
Ruy, as a teacher and a mentor, how do you apply that in your supervision and your teaching?
So that, I think, it's the learning part, let's say studying, it's an individual effort. So what the mentor has to do, or what I try to do, is to encourage and explain why that is important. So, and of course, answering questions and all that, that goes without saying. But I think the important thing is to show that developing that enthusiasm for whatever maybe is not your exact expertise. So if you're a modeler or a more mathematical background, then that understanding the rest and making that effort is important to really be better at what you do. I think that's what I maybe try to encourage, and to explain that sometimes reading other papers is more difficult, but it is worth it to be able to do better models.
So what's your why? What's your motivation? Why do you do what you do? What makes you wake up early in the morning or working long hours?
I mean, I like what I do. I really enjoy understanding. I've to develop this understanding of how nature works in all fields is something that has always fascinated me. And in this particular field, there's this medical applications. There's this. We know that we hope that some of the insights that are developed will have an impact and will be maybe able to improve people's life, or at least improve our understanding of these pathogens. And I think it's fascinating, this interdisciplinarity of biology, immunology, pathogenesis, virology, and try to do quantitative. And there's so much to be done that I think it's really a great field to work on.
I'm pretty much on the same page as Ruy that this field offers so many interesting questions that mathematics can sort of provide some insight into these interesting phenomena that it's occurring. That's sort of why I got into, I'm going to say mathematical biology, is there's all these interesting questions and we can apply these mathematical models to provide some insight as to what's going on with these phenomena. I think what sparked my interest was back in my undergraduate. I had a mentor who was interested in epidemiology. I was actually doing a degree in financial mathematics, and just that experience itself, that the application to apply mathematics to something that could benefit the community but also spark my interest in complex problems, is sort of why I do what I do.
Thank you very much for sharing. To motivate young people in this field, practical tips or practical tools how to be successful?
Well, I think the main tip is be curious, because as we've been talking about, this is some of, if we really think about this field of trying to bridge immunology or virology and modeling, then you need to learn new things, most likely that are outside what was your formal education in your undergraduate or PhD or whatever. So you need to have that curiosity, and then there's a lot to read out there to try to gain ideas. And then the third thing would be perhaps try to talk with people that are in the field, and try to see how you could also contribute and get the education or the on-the-job education, research experience to be able to do that contribution.
I think the biggest advice that I can offer from personal experiences, is trying to overcome that hurdle of learning something new that's very complex and complicated. Personally, I hadn't taken a biology class since high school, so finishing my PhD, which focused on epidemiology of influenza, and then jumping into HIV infection within host, to me it was a very steep learning curve, and it was just pushing through that hurdle of trying to understand the biology associated with HIV infection. And I'm still encountering hurdles every day, and just reminding myself to push through those hurdles and obstacles, because I know it's benefiting myself. So that's the biggest thing I can probably say, is push through these hurdles, and it's probably going to be, it's going to work out for its best.
Yes, you can. Thank you very much for your time. I will not stand any longer between you and lunch, and have a great time here in Colorado. Cheers.